The independent practice reviews much of the same things that we just did in our explore sections. So we did things about walking rate and how to calculate it. So please go back and use what you've already learned to answer these questions. But just a couple reminders. So it says here, Hoshi walks 10 meters in 3 seconds. What is her walking rate? Remember, we were using the units meters per second to answer this question. So how could you use 10 meters in 3 seconds to find the walking rate? And I'm going to encourage you to go to the 10th place, so one space after the decimal, to when you're calculating this, if you have a long number like we did for our walking rate, just go to the 10th place. That'll be okay. And then you're going to repeat very similar things to what you just did in the problems in part B. So it says, at this rate, how long does it take her to walk 100 meters? So you could use that proportion to set it up. You could also find another way to do this as well. You might be using multiplication or division, but take a look at it and see what you did in part B, and you'll be using the same idea here once you've found that walking rate. So you're going to need A to answer B here. And then it asks, she walks the same rate for 50 seconds. How far can she walk? So remember, this is seconds. This one was, we knew the meters. So you're going to have to calculate these in 2 different ways. And then it finally asks you to write an equation to represent the distance, d, that Hoshi walks in t seconds. And remember, our equations should start with d, and then on the other side here, there should be a t involved with it as well. And it should also include the walking rate from A. Remember, your walking rate is a unit rate, which also means that it's a constant of proportionality. And so you should be using that number in this equation. Then in number 2, it says Milo walks 40 meters in 15 seconds. Mira walks 30 meters in 10 seconds. Whose walking rate is greater? So this is very similar to the problems we did last unit, where we're looking at unit rate. So I encourage you to find what's the unit rate for Milo, what is the unit rate for Mira, and then figure out who has a greater unit rate. And that unit rate, remember, is just their walking rate, however many meters they can walk per second. On problems 3 through 6, it says we're going to look at the unit rate and then write an equation. So it says here, I'm going to give you just one example, and then every one of these is going to be really similar. So Maria ran 5 miles in 57.5 minutes. How long did it take her to run each mile? Then write an equation to represent this. So we have miles and minutes, so we can find out how many miles per minute. Remember, we're just finding out our rate, the miles per minute, and then you're going to use that rate to write an equation. And again, in this case, we can use distance and time because we still have distance and time. But in the future problems, we don't have just only distance and time. We have things like the cost and the pounds of potatoes. So you could use other variables than D and T. So if you wanted to represent cost with C instead of the T or the D, that's fine too. And pounds, you could have P as your variable. So when you're writing these equations, you might have different variables written out than what is in the key. The important part is, does the letter you are using to represent money, is that still in the same place as what the key says? That's what's important here. So you're going to try to find out the unit rate and write an equation for each one of these. And the unit rate needs to be involved in the equation. And then finally, you have a summarizing question that just says, how can finding unit rate help you write an equation? So reflecting on how did we write equations from here? All right, make sure that you're checking in with your teacher and checking in with the key.